This video is the building instruction for a precise filament rewinder. I have uploaded the 3D printing project to printables.com. You can also find the link pww2.com/printables in the video description. The building instructions are divided into 7 sections. Let's start simple. The first section is about the main plate. In the second section, we install the first moving part, the so-called ratchet. Its task is to ensure that the spool does not rotate backwards and that the filament is always kept under tension when rewinding. The ratchet can also be folded up during operation and thus deactivated. The most complex section is the assembly of the gearbox. It consists of 7 so-called herringbone gears. The red gear wheel forms a unit with the so-called double helix. The double helix consists of 2 counter-rotating spirals, each with 2 windings. This helix is responsible for the precise guidance of the filament. The gear has a transmission ratio of 17.4:1. The double helix has 2 spiral windings, consequently, it requires exactly 34.8 turns of the crank to wind 1 filament layer. In the next section, we assemble the most important part for the filament guide, the so-called rider. It is firmly mounted on the spiral shaft. The actual filament guide is slid into the dovetail groove of the rider and adjusted. Once the gearbox and the filament guide have been installed, the housing can be assembled. In the last section, I describe the assembly of the coil holder, the assembly of the coil and finally the final assembly. At this point you will also find a real video showing the assembled device in operation. It is powered by a cordless screwdriver. The crank can simply be replaced with an adapter for a flexible shaft. Now have fun watching or maybe even rebuilding the machine. We need the main plate and 4 bearings with an outer diameter of 22 mm. The 4 bearings are pressed into the large holes by hand. Please make sure that the bearings protrude by about 0.5 mm at the front and rear, i.e. that they are pressed into the center of the main plate. Print out the measuring gauge for this. To do this, place the measuring gauge on the back under the bearings. Carefully tap the bearings from the front with light strokes until they reach the stop. This completes the first step. We now install the ratchet. It is the part labeled 1 in the print file shown below. It is attached at the top right with a washer on the front. We need another washer on the back. The ratchet is attached from the front using a 20 mm M3 screw. The ratchet is then screwed tight from the rear. Only tighten the nut so that the ratchet can move easily. Now attach the tension spring that keeps the ratchet under tension. The spring is attached to the ratchet and the housing with 1 M3x8 screw each. Step 2 is now complete. The following step is the most time-consuming part. Now the gears have to be assembled in the correct order. This involves a few details, which I will go into in more detail. The picture shows the arrangement of the gears. Gear wheels of the same color are located on one axis. Gear wheels that mesh with each other are called corresponding gear wheels. So-called herringbone gears are used. It is important to know that corresponding gears must always be in opposite directions. This is particularly important for gear wheel Z3, as it is symmetrical and could therefore be inserted incorrectly due to carelessness. The herringbone toothing is also the reason why a corresponding gear wheel cannot be inserted vertically to the axis of an already mounted wheel. As a rule, corresponding gears must always be inserted together, i.e. parallel and vertically into the corresponding bearings. Short screws are inserted into the helical gear and the spacer gear. These only have the function of reinforcing the gear axes against shear forces. After this short side step into theory, we now continue with the assembly. We assemble the first group of 3 gears. We prepare these first. Screw an M3x14 reinforcing screw into the helical gear wheel. Do the same from the other side with the distance gear. Insert an M3 nut into the small gear wheel Z4. The next step is to insert these gears in parallel into the matching bearings. To do this, we clamp the center gear between the 2 outer gears. In doing so, we determine how stable the herringbone teeth hold the gears. Now insert the group of gears into the bearing bushes. Now we continue working on the rear side. We need the large gear wheel Z3, the one with the 5 holes, and the small gear wheel Z4 with the quick release axle. It has 11 teeth. We insert an M3 nut into the latter. Place both gears together. We should already pay attention to the orientation of the square hole of Z3 so that it has the same orientation as the axle of the already installed Z4 gear wheel. Now slide this arrangement into the bushing or onto the quick release axle. Use an M3 washer and an M3x25 screw to connect the Z3 and Z4 gears. Now we install the 2 remaining gears. To do this, we first prepare the input gear by pressing a 22mm bearing into it by hand. We now need the last large gear wheel Z1. We place this on the input gear as usual and then slide both gears together onto the stub axle or the axle of the main plate. Finally, we attach Z1 to the quick release axle of M2 using an M3x30 screw and a washer. Now we must first prepare the axle spindle. After printing, please take great care to ensure that the grooves for the square nuts are free and that there is no more support material in them, especially at the ends. Otherwise you will not be able to insert the nuts as far as they will go. If necessary, clean the grooves with a small screwdriver or a Dremel tool. If everything is in order, insert the M5 and M3 square nuts. Check that they are seated correctly. Now we insert the 2 matching end pins. I have glued these with Woolfix superglue and activator. The axle spindle is now prepared and can be used. With the narrow side, i.e. the side with the M3 nut, we now insert the axle spindle into the input gear or onto the bearing and screw it on from the rear using a washer and an M3x35 screw. Tighten the screw fairly firmly. The filament guide system consists of 2 main parts, the so-called rider and the actual filament guide. The rider is responsible for ensuring that the filament layers are wound as precisely as possible. It guides the filament from one side to the other. The rider consists of two parts. The rider cannot be assembled separately, it must be mounted on the double helix. For the assembly instructions, we have once again detached the double helix from the construction. This is for the sake of clarity. Firstly, let's take a look at this T-piece. It engages in the groove of the double helix. If the double helix gear wheel rotates twice, this T-piece, and therefore the entire rider, is guided horizontally from one side to the other exactly once. We now insert the T-piece into the corresponding hole in the right-hand half of the rider. We retain the orientation of the T-piece so that we can insert the rider together with the T-piece onto the shaft. We have previously prepared the other half of the rider and inserted 2 cubic meters square nuts. These are closed with the 2 printed pins. We take the prepared second part of the rider and join it to part 1. At the same time, insert the 2 plain bearings. They are held in the rider by 2 edges, provided they are centered. Not explicitly shown in the video but important, the 2 halves are now firmly connected with an M3x14 screw. The screw is inserted from the right-hand side. At the end of this step, you can see a section through the assembled rider here. We now assemble the second part of the filament guide system. To do this, we insert a piece of PTFE tube. We need approximate 20 centimeters. The filament is held under tension by 2 clamping rollers. We now prepare these. To do this, we press an 11 mm ball bearing into each of the rollers. Then insert the prepared rollers into the slot in the filament guide. Now insert 2 M5x35 screws into the hole or slot. Fasten them with 2 nuts and pull 2 rubber rings or sealing rings over the ends. Now we can plug the 2 parts of the filament guide together. We have already fitted the rider to the double helix, which is also already installed as part of the gearbox. We simply slide the completed filament guide onto the dovetail groove. Finally, we fix it in place using an M3x8 screw. The filament guide will later be adjusted with this screw. We have now completed this somewhat more complicated step. Now we can finalize the housing. We need a total of 14 cubic meters x 20 screws. We attach the top strut, the center strut, the base plate and finally the base strut one after the other. Then we prepare the front panel. We press in a 22 mm bearing for this. Before we fit the front panel, we need the guide rail. We first insert it through the slide bearings of the rider. It is pressed into the bushing of the main plate until it ends at the same level as the helix shaft at the front. Then we carefully slide the front plate onto the shaft and press the guide rail into the front plate socket as well. Finally, the plate is secured with 7 screws. Now the winder is almost ready for use. Now we can finalize the device. Here you can see the entire spool holder including the coil as an exploded view. The spool holder consists of a plug-in axle and crank, as well as the actual holder onto which the coil is attached and which is pushed into the housing. Instead of the crank, an adapter for a flexible shaft can also be attached so that the device can also be driven with a cordless screwdriver. The adapter is part of the print file, but will not be discussed further in this section. Firstly, we assemble the crank, consisting of the main part, a small bearing and the handle. To do this, we press the bearing into the hole for the crank handle. The parts are bolted together using an M5x35 bolt and a suitable washer. We need 2 more 11mm bearings for the through axle. One bearing is inserted from the open, wide side. Make sure that it is pressed right up to the stop, otherwise we will not be able to connect the axle to the gearbox later. We can also insert the bearing with an M5 screw. Now press in the next bearing flush from the narrow side. Now we can put the through axle and the crank together without screws or tools. We now prepare the bobbin holder by pressing the large 35mm bearing almost flush from the open side. It should protrude by about 1mm. Finally, press the spool caps onto the PRUSAMENT spool. The slot and groove must be aligned. The cap with the 3 elongated holes faces the gearbox, the closed cap here faces the bobbin holder. Now we can loosely plug all the components together. Finally, we insert the M5x 70mm screw loosely into the quick-release axle. It is pushed through to the other side. This screw is used to attach the bracket to the housing. We put both parts together and tighten the prepared M5x70 screw. It is sufficient to tighten it loosely. In any case, it must be possible to move the coil easily.